So just to illustrate this concept of circular permutation, I take you through an example, a pretty simple example. We're talking of a roundtable conference to be held between 20 delegates of two countries. 20 delegates of two countries. In how many ways can they be arranged if two particular people, two particular delegates are one, always together, never together, are always together, never together, all right? So first of all, if there were 20 people to be arranged in a circle, n things to be arranged in a circle, then the number of permutations, circular permutations, is going to be n minus 1 factorial. So if 20 people, if there were no restrictions, without restrictions, what would have been the total count? Without restrictions, the total count would have been 19 factorial. Would have been 19 factorial. 20 minus 1, n minus 1 factorial. But now, two particular people in this set of 20 delegates, we want them to be always together. So what we do is, we put these two people, say call them P1 and P2 together. And then we have, so count this as one unit. Count them as one unit. And then we have the remaining 18 people, 1, 2, 3, etc. We have the remaining 18 people. So we then have essentially 19 units. This 18 people and this one, that's 19 people. And 19 people to be arranged in a circle with P1 and P2, let's say, packaged together. P1 and P2 packaged together, then the count would have been 18 plus 1, 19. N things, right? So there are 19 things. So 19 minus 1 factorial, n minus 1 factorial, right? But realize that I could have had P1 P2 or P2 P1. The packaging of P1 P2 together could have been like P1 P2 or P2 P1. So that means if it's P1 P2, it's 19 minus 1 factorial. If it's P2 P1, that would also have been 19 minus 1 factorial. And they're different. P1 P2 and P2 P1 are different. So that's essentially like 18 factorial into 2. That would have been the count. So these would have been the number of cases they are always together. And the total number of cases would have been 19 factorial. So in the remaining cases, they will never be together, right? The total count is 19 factorial. This is the count in which they are always together. So the remaining cases never together would have been like a 19 factorial minus 18 factorial into 2. That would have been the count. Yes or no? Right? So I hope you know. So circular permutations are important. It's important to get a basic hang of things. This was a very simple problem, but we'll do more problems and get abreast with these basic ideas in a better manner. But this much for this time. Thank you so much. Bye-bye.